All right, sometimes when we have a polynomial that we're going to divide using synthetic division, we have some terms missing. So, for example, and I'm going to skip this one because it's kind of uneventful because it has a bunch of ones in it. So we're going to take a look at this guy over here. So we won't do two of these, we'll just do one of them. So in this case here, when we look at this, what I want you to see here is that, obviously I have my x to the fifth, but there's some stuff missing. Like, for example, there's an x to the fourth missing. And there's an x cubed missing. And there's an x squared missing. And there's an x missing. And then we've got the very end, which is plus 243. And all of that is being divided by x plus 3. So we need to put something in those places right there to hold the value or hold the place but not change the value. Well, if we put in a 1, that makes the value be where there's like something like it was there. So instead we put in zeros. So we put in these placeholders. So this is when we're doing synthetic division when this is really important. Even if you did long division, you need to put those zeros in there, but we're focused on this method of synthetic. Okay, so we got our zeros. Now we go ahead and we set it up. So we're going to do leading coefficient of 1, coefficient 0, coefficient 0, coefficient 0, coefficient 0, 243. All right, we have a factor of x plus 3. So if our factor is x plus 3, then our 0 would be x equals -3. So we're going to test -3 and see if it works. We bring down our 1. -3 times 1 is -3. We place it right there. We add those together, we get -3. A -3 times a -3. So we multiply those together. We put the product right there, which is 9. We add those together, we get 9. A -3 times 9, put the product right there, that's -27. We add those together, we get -27. We take -3 times -27. I don't know what that is. I think it's 81. 27 times 3. Yep, 81. So that would be -81. We add them together, we get -81. And last but not least, we take the -3 times -81 and we get positive 243. So let's see, something went wrong here because this should work, I believe. So 1, bring it down, negative, that's a negative, add, negative, the negative gives me a positive, add, negative, positive gives me a negative, add, and there's our mistake right there. My mistake, not your mistake. That should have been positive 81 and positive 81 because a negative times a negative is a positive. So that makes this last piece a negative 243 with a remainder of 0. So if we divided x plus 3 into this nasty polynomial, into this guy right here, our product would be x to the fourth, because we started as x to the fifth, so we go down 1 degree, minus 3x cubed, plus 9x squared, minus 27x, plus 81, with a remainder of 0. All right, so that's using our long division to plug that in. And just as a side note, your remainder theorem. So if you did your remainder theorem, remember that means that f of -3 would be equal to 0. In this case here, this would be one of our zeros. All right, so let's hit pause and see, maybe we can double up this video. All right, we'll call that video right there. And this will be a video where we're talking about replacing those missing terms with zeros.